the phone and also recording on my computer as well. So hopefully we can pass this version along. So again, my name is Jeff Vorok. Appreciate you guys giving me a little bit of time to kind of give you some insight into the winter weather season and what NOAA released really a couple weeks ago. We're kind of looking ahead to how the winter might play out. You see my email address up there, so if you have any questions or want to follow up, it's just jeff.orok@noaa.gov. That's the best way probably to get hold of me. So getting on into what the outlook is and what we're looking at. So thinking about what do we usually expect, around Norfolk, ORF there, for a typical winter. How much snowfall do we usually see? And so the area typically sees around between 5 and 6 inches of snow, every year. And really what that means is if you look at the climatological record and you say, okay, every single winter over the last, let's say 30 years or so, you average that out. Say, okay, how much snow did you have on average, over a 30-year period, and that gives you about 5 to 6 inches of snow. The reality is that really never happens. You never get that exact amount of snow every single year. It just doesn't work that way here in the Mid-Atlantic, and especially along the coast. So what ends up happening is you have years where you get a lot of snow. You look at Norfolk down here in the bottom right-hand corner. You have some winters, our maximum has been 41.9 inches of snow. That's an insane amount of snow. That's the most we've ever had in a winter, and the least we've ever had in a winter is 0. And then that does happen with some frequency where we'll go an entire winter and have no measurable snowfall. And so, what ends up happening is our winter snow really becomes an average of extremes. Either we get a little bit, we get a lot, or we get 0. And then you average all that out, and it ends up being somewhere around 5 to 6 inches. That's that average. The median, if you're in a statistic type person, is only about 4 inches or so. So we really do deal with an average of extremes. It's almost like some years we have a lot, some years we get a little, some years we get absolutely nothing. And so, to say what's the snowfall climatology, what's normal for snowfall in our area, there really isn't what I would say a true normal snowfall for Hampton Roads in Southeast Virginia. So what's the outlook for this season? Knowing that our winters are so variable, we do see quite a bit of different types of winter weather. So what are we expecting this year? Well, there's a pretty strong signal that is in regards to temperatures that a lot of the deep south and even the mid-Atlantic, we have really good chances of seeing above normal temperatures on average. So what that means is, the average temperature from December all the way through February, if you average all that out, there's a pretty good chance that on average our temperatures are going to be above normal. And that's really true for most of the U.S. Everybody you see there in the browns and maybe the reds and the oranges, those are the probabilities here at the bottom that you're going to be above normal. So our probability is about maybe 40 to 50% chance that we're going to be above normal temperature-wise. Looking at precipitation, for us, the signal is not quite as strong. You do see most of the south, showing a signal that's going to be drier than normal, maybe not quite as wet of a winter. So again, this is looking at your average rainfall and snowfall, all precipitation combined from December to February. What do they think that might look like? And the thinking is on average that most of the south will see below normal precipitation, and that'll bleed up a little bit into the mid-Atlantic where we do have a slightly increased chance of having a drier winter. So what does all this mean? It's all based on probabilities. And why is the signal pretty strong for temperatures? What is NOAA really hanging their hat on here to put out this type of a prediction? And what a lot of this gets back to is this La Nina pattern in the Pacific Ocean. And so to really define La Nina here in the bottom right-hand corner, this is a loop of sea surface temperature anomalies that was going on out there in the Pacific, and it's still going on. This has been happening since really spring and summer, where the Pacific Ocean, the sea surface temperatures have been much colder than normal. And so you're seeing that blue area spanning across the Pacific Ocean are really below normal sea surface temperatures. So the Pacific's been cold. And so what happens is when it's cold out there in the Pacific Ocean, you don't have a lot of thunderstorm activity. It suppresses all the convection. There's not a lot of energy out there. And so when that happens, it really weakens the jet stream that flows, from west to east across the Pacific and eventually across the United States. It gets weakened. When there's not a lot of thunderstorm activity, there's not a lot of heat, not a lot of energy, it actually weakens the jet stream. And that's what hurricanes love. hurricanes like light winds, they like stagnant conditions, and so that's why we've had such an active hurricane season. Now it's been very focused on the Gulf of Mexico, but the fact that we've had this La Nina for so long in the Pacific Ocean really amped up the hurricane season and made great conditions for that. Well, if these same conditions persist into the winter and the jet stream remains, fairly, let's say just say fairly weak, it also remains a little bit further to the north. This kind of shows you the average flow of the jet stream. And so with it maybe being a little weaker, more displaced to the north, that takes all the cold air precipitation with it, further to the north. And so a lot of the deep south and even the mid-Atlantic can get a little bit drier and a little bit warmer than normal. And so that's really what they're banking on is this La Nina. Now, there are other weather patterns that come into play that I'm not going to get into today that actually will cause, weather swings, about every 2 to 4 weeks. I mean, sometimes you can still have a cold outbreak that lasts a couple weeks, and then you go right back to maybe being fairly warm again. So, it doesn't mean we won't see flip-flops. It just means on average, things will probably be a little bit warmer than normal and potentially a little bit drier than normal because of the La Nina and because of this decreased jet stream. The other thing that this weakened flow and a little bit farther displaced jet stream can do for us is that the jet stream is a big player in our nor'easters and our coastal storms in the wintertime. And typically we see around 12 to 15 coastal lows, in a season. That's how many we expect to kind of go along the coast, let's say from November to like March or so, March and April. So if the jet stream is farther north and a little bit weaker, it could decrease the frequency in nor'easters and coastal storms. So we may not see as many of the big coastal storms this winter. Doesn't mean we won't get one. It just means we may not see the frequency of coastal storms that we typically experience. You guys know sometimes we can get one every 7 to 9 days. Sometimes we get a low pressure system scooting up the coast. So the frequency of that may be decreased here a little bit this season. Now, does this mean no snow and that it won't get cold? Well, all of our snow lovers, they say it ain't so. Well, the reality of it is, winter weather is so variable here, and there really is not a strong signal at all. There's really little to no signal with respect to our seasonal snowfall in La Nina, just because snowfall here is kind of fairly chaotic as it is. And in fact, when you look at the climatological record, our weather records, and you look at those past years where we had these La Nina conditions in place, and you compare those winters, to what may happen this winter, what's really interesting is La Nina winters are really the most variable, meaning that when we're in these type of patterns, we usually see very large swings in temperatures. It may get fairly cold for a week or so, or 4 or 5 days, and then all of a sudden get really warm. So we do see like a huge roller coaster ride a lot of times in this La Nina pattern, where we get a little dip in the jet stream, we get cold, we get maybe a little bit of moisture, maybe even some snow, and then all of a sudden the jet stream retreats back to the north and everything goes warm again and gets dry. So we could see some fairly dramatic swings this winter. What's really interesting to note that 4 out of 5 of our snowiest seasons, where we've recorded the most amount of snow since about 1949, have been La Nina winters. So we have seen some really big snow events with this La Nina pattern. So despite maybe the overall winter maybe being, above normal temperatures, you could still get a big snowstorm. Some good examples that some folks might remember, we had this Christmas snow back in 2010 where it started to snow really late in the afternoon and evening on Christmas Day. And Norfolk ended up racking up almost 13.5 inches of snow that fell Christmas night into December 26th. And that's where this record event here, where you see this huge spike right here where this arrow is. The entire season that winter, we had almost 21 to 22 inches of snow, and 13 inches of that fell on Christmas night into December 26th. And that was a La Nina year. What's amazing is that by New Year's Day, the temperatures were back in the 50s and 60s. I mean, way above normal, and the snow was gone. So a huge roller coaster ride there where the kids got to have snow at Christmas, and then by New Year's, it's 60 degrees. I mean, some folks probably out there almost in shorts by that point. We also had the blizzard of January 3rd and 4th, 2018. A lot of you will remember this one. This was the last real true blizzard we had here in Norfolk. We got 13 inches of snow again, and it stayed cold for several days. We had about 4 or 5 days where the temperature never got above freezing, and that's marked by this arrow right here. So that was a pretty good wallop of a winter, where we had most of the snow that winter in Norfolk came in that one event. If you notice, we only had 15 inches total, and 13 inches of that came in that one storm. So really one big storm for the year. It was a huge hurrah. It got very cold for about 4 or 5 days, locked up everything. But then all of a sudden by January 11th, we're back in the 60s and 70s again. I mean, another huge roller coaster ride. So again, this really, I think, kind of paints the picture that, it doesn't mean no snow. It doesn't mean we could still have a big storm, but we do expect maybe some pretty dramatic flip-flops in our weather this winter. So some of the decision support tools, some things you can look at to try to, gauge our forecast and try to use in your own planning. We're going to talk about the snow probability webpage. This is what our snow forecasts look like nowadays. It is fairly involved. We basically will tell you, how much snow we think is going to occur, how much, the worst case scenario, as well as like a least amount. And then we also try to explain, what's the chance of getting 1 inch of snow, 2 inches of snow, 4, 6, 8, 12, and 18. So you kind of get a good confidence in the forecast, So we'll kind of show you how this works. The way you get to our winter weather webpage is just weather.gov, /AKQ and then /winter. And really the easiest way, if you're really familiar, I'll drag the website over here. If you're familiar with our webpage, you basically just go to weather.gov /Wakefield, scroll down the page, and all you have to do is click on this little snowflake icon. You click on the snowflake icon, and it opens up the probabilistic snowfall page. And actually, I'll go back to the snowfall forecast right here. And so, you can see here our official snowfall forecast would go in this block. Our worst case scenario, which I'll explain what that means, would go here in the upper right. This low wind amount is just telling you, okay, expect at least this much snow. That doesn't necessarily mean a whole lot. A lot of times you're focused on what are you expecting, what's the exact forecast, and what's our worst case. And I'll kind of explain that. And as you go down the page, now you have your probabilities of seeing, okay, if I want to know what's the chance I'm getting 4 inches of snow, what's the chance I'm getting 6 inches of snow, this will give you that type of information. And then what's even neat, if you continue down the page, now you get actually probabilities for different jurisdictions. So let's say, I want to go down here. Let's say I live in, we'll just say Chesapeake. So I click on Chesapeake, and here's different locations around Chesapeake, and it gives me, my expected snowfall amount, what my worst case snowfall amount might be, and then what's the chance I'm going to see different snowfall accumulations. So good example is maybe we're forecasting 4 inches of snow. Maybe our worst case scenario is about maybe 8 to 9 inches of snow, and maybe your probability of getting 6 inches of snow is maybe 40%. So it's a decent chance you could get up to 6. So it's different ways you can be able to interpret this, but it's a great resource. And again, it's just right on our webpage, weather.gov /Wakefield, and click on that little snow icon. So I'll kind of walk through a little bit of what's going on here and what these probabilities mean. Because they can get misinterpreted, and it is kind of important to understand a little bit behind, what's going on here. So again, we talked about these tables, and so this is just an example that we pulled off the web. We'll just find somebody's got some snow. We'll do Inner Harbor, Maryland for this example, and they were expecting about 3 inches of snow. Their worst case scenario was 6 inches of snow based on the table. The chance that they were going to get 4 to 6 inches of snow was about 20%. So, not a real high chance, but, if you're trying to be a planning person, you say, okay, well, there's a 20% chance we could get up to about 6 inches of snow. The chance of getting up close to maybe 6 to 8, that's down to almost about 11%. So that's getting pretty low at that point. But it gives you an idea of the probabilities when you go down to the bottom of that web page and look at the tables. So here's an example of a really heavy snow event that really struck the western part of our forecast area, got up into Richmond, where we were forecasting, 8 to 12 inches of snow. And in the city of Richmond, we were forecasting right around 4 to 6 inches of snow. But you notice the 6 to 8 was right on the doorstep of the city of Richmond. So we're forecasting 4 to 6. 6 to 8 inches of snow was not that far away. What's really amazing is if you looked at their high-end amount, or what we call the worst case scenario, the worst case scenario for Richmond was 11 inches of snow. So what the heck does that mean? So the 4 to 6 inches is our forecast, and our forecast usually kind of sits in right in the middle of all of our what we call our weather model distribution. And so this becomes a statistical analysis. And in the 50th percentile, meaning that our forecast, along with half of all the weather models, are saying 4 to 6 inches of snow. The 11 inches is coming from the fact that we're running a statistical analysis on about 70 plus weather models. And the worst case scenario is telling you that, okay, up to about 90% of all possible solutions can take you up to 11 inches of snow. So if I want to take into account just about everything, including the kitchen sink, when it comes to the weather models, some of the weather models that may be just going crazy, what's my reasonable worst case? And that's where you get the 11 inches. So it's a statistical distribution. So it actually is telling you some of the weather models out there are actually forecasting that much snow. We're not just making that up. There is some guidance out there that's showing some pretty heavy amounts. So if I want to dial it in, and let's say I'm in the city of Richmond and I want to say, okay, what's the chance I'm going to get 6 inches of snow? What's the chance I might be on that higher end of 4 to 6 inches? Well, it's a 40% probability. So that's 41% here. That's a pretty good chance. That's telling you that literally 40% or 41% of all the weather models are predicting at least 6 inches of snow. Some are predicting even more. So that's a pretty hefty distribution. And our forecast is usually right around that 50 percentile. We call it the 50 percentile. So you got to be careful with this. When it says 41% chance of 6 inches of snow, that's a pretty decent probability. There's a lot of guidance out there suggesting that it could get up to 6 inches. Chance of 8 inches of snow, still 27% chance. So that's telling you 27% of about 70 different weather models are predicting about 8 inches of snow. So that's still, I would say, statistically, significant. I mean, it's not just a few weather models saying you're going to get 8 inches or more. It's a fair number of them. So that's a good way to kind of digest that, saying, okay, they're forecasting 4 to 6 inches. There's about a 27% chance we could get upwards of 8. So kind of a good way to kind of balance that. And in this case, Richmond picked up about 7 to 8 inches of snow. They got a little bit more snow than what we were initially predicting. And this guidance here kind of led you to kind of that direction, saying, okay, look, 27% chance it could be 8 inches. So I just want to keep that in the back of my mind as far as resources I might need for snow removal and things like that. So here was the blizzard of 2017 that hit Hampton Roads. And this is all the different forecasts. In the upper middle is our forecast. So the 50th percentile, which we call it, this gets into statistics, and I'm not going to go down that rabbit hole too far right now. But this is our forecast up here in the upper middle. And so it's showing widespread 8 to 12 inches of snow across all of Hampton Roads, and then down to 4 to 6 inches when you get up towards Richmond. As far as the worst case scenario, the high end amount, notice how it's a foot of snow, 12 to 14 inches of snow across a large portion of central Virginia and even down here into southeast Virginia and Hampton Roads. So could be up to 14 inches of rain here, snow for Hampton Roads, maybe even a foot in Richmond. And we're forecasting 8 to 12. So what are the chances I'm going to get different amounts? So the chances I'm going to get 6 inches of snow, let's say down here around Norfolk and Portsmouth, it's pretty high. I mean, it's almost about 70% or so, 70, 75%. So that's really high. That's telling you that 70% of all the weather models are saying at least 6 inches of snow. That's a slam dunk. 8 inches of snow or more, I mean, you're still over 50%. And so again, we're actually forecasting 8 inches or more. So 50%, very high probability. The chance you're going to get over a foot, about maybe 20% chance, maybe 20 to 22% chance. So it's not zero. And in fact, we did actually push about 12 to 13 inches of snow. Here we were forecast at 8 to 12. There's about a 20 to 22% chance you're going to get that high. Not everybody saw that 12 inches, but we did average about, I'd say 8 to 12 inches was a pretty good average in that event. So a good way to kind of interpret, what's going on. So you're not just stuck with somebody telling you, okay, we're forecasting 8 to 12 inches of snow. And you can say, what's the chance it could be more? What is the chance of that? So it gives you a little bit more information. The last thing, which I hope a lot of you guys are really familiar with, are the hourly weather graphs. They're really easy to use. They're very easy to access. So I'll just really reiterate how to get to our hourly weather forecast so that folks kind of know how to navigate to it. I'll pull this back up. So just go to weather.gov/Wakefield again, or AKQ, and just click on any location on the map. So I'll go over here and I'll just click on the Norfolk area. And when the Norfolk area comes up, then what I'll do is, so I'll see my forecast for where I click. So there's my green dot. You can re-navigate this. If I want to go out to Cape Henry, I can move it out to Cape Henry, and that will give me the forecast out there at Cape Henry. You get your awarded forecast, but if you scroll on down to the bottom, this is really where probably the most detailed forecast is in this hourly weather graph. And so when you click on it, it's accessing the database. Seems like it's running a little bit slow, but it pulls up the detailed forecast, hour by hour of temperature, wind, your snow, your ice, your freezing rain. Here you go. So you got your temperatures at the top. You got your wind direction and wind speed. Here it even tells you when the winds are going to pick up and get kind of gusty. The brown line here is your chance of precipitation. So you can see that's really low. The blue line is actually sky cover. So if you're interested if it's going to be cloudy or sunny, obviously if you have a high percent of sky cover, it's going to be cloudy. If you have a low percent of sky cover in the blue, it's going to be sunny. And then underneath that, what's going to fall from the sky? Is it rain? Is it thunderstorm, snow, freezing rain, or sleet? So it gives you an idea of the timing of everything. And this forecast does go out to 7 days. So I can, hit forward 2 days and jump out ahead in time to get further out into the future. So really a great resource with the hourly weather graph. And so, right here is a good example of a snowstorm coming up the coast where, you're looking at your chance of precipitation here in the brown going from 50 to 60 to even almost 90% chance. When is the rain going to change over to basically, freezing rain and sleet? So you can say, okay, by about 3 a.m. in the morning, we're going to start mixing with rain and freezing rain. Then it's going to change over to sleet about 6 a.m. and then really should be all snow by about 6 p.m. in the evening. But what's really interesting here and kind of dangerous is you see a prolonged period of freezing rain and sleet, which can be pretty bad. And you look at the temperature, and the temperature is 30 degrees. So you hold 30 degrees and have freezing rain, you can get a lot of accumulation of ice in the trees. And so this would be a fairly interesting situation. We might be expecting a fair number of power outages. The other thing you can get out of this is if you think about you're getting ice accumulation here, and then you get ice in the trees, and look at the winds picking up. So, if you do have ice-laden trees and all of a sudden the winds increase, that's going to be very problematic. You're going to have a lot of weight in the top of the trees swinging around, and that can actually help to bring the trees down. So there's a lot of information you can actually start to ascertain from these hourly weather graphs with a lot of detail being provided here. The last thing I'll mention before we let loose here is we do have a website to develop just for the port. It's just weather.gov/AKQ. And then after you pull up our website, just type in the words DSS_port. And we can make sure we email this out. This was developed several years ago to kind of help support port operations so that everybody was kind of focusing in on the same information. And so I won't go through all this in detail. We do have a YouTube video we can share on how to use the page. You see the current conditions show up here. We have wind and buoy data that we link to, so you can look at what the buoy data with the wave information is along the coast. The snow and ice forecast takes you right back to the snow and ice forecast page I showed you earlier. This will take you here. The upper right-hand image of the watches and warnings takes you to our website. Of course, the radar is on here. As you mouse over, it will actually populate the middle window with whatever you're mousing over. It's got a nice mouse over function. As you scroll down, you have the wind forecast, basically the sustained wind forecast every 3 hours. What's the maximum sustained wind we're forecasting through 72 hours? What's the maximum wind gust through 72 hours? Same thing with the wave height information. Wave heights every 3 hours. Maximum wave height over the next 72 hours. This is just telling you the risk of severe weather the next couple of days. We have tide information in here. So basically a quick glance at what maybe some of the different tide locations are doing. This is all based on mean low or low water. And so you can kind of get a quick glance at least at some of the tide gauges around the port to see what's actually happening. We do have wind probabilities in here. We have another YouTube video that explains this. It works just like the snowfall probabilities. So if I want to see the probability of seeing different intensity wind gusts, let's say at Chesapeake Light, this gives me kind of that information. So you can see a really high probability here as we get into the 15th at around, this is local time, so this is about noon. Real high chance it's going to be gusting up to about 25 knots. Very low chance it could be gale force of 34 knots. And again, this is a statistical analysis that includes our forecast and about 70 plus different weather models. And if you want to see more wind probabilities, just come down here, click on this little icon here where you see the wind probs, and it actually opens up the entire wind probability interface. And so like I said, there's another whole tutorial that gets into how to use this interface because you want to make sure you're interpreting it correctly. I will say the winds here at the bottom of the probabilities is our forecast. So down here is the National Weather Service forecast, and then the graphs are the probabilities of seeing different wind speeds based on a whole array of different weather models and a statistical analysis. So here's a good example. At buoy 9, we're forecasting south winds gusting up to about 30 knots. The chance of it being 25 knots or greater is almost 100%. The chance of gale conditions, which is 34 knots, is about 20%. So we're not forecasting gales. We're not forecasting gusts of 34 knots, but there's a 20% chance it could be. So it kind of gives you a little bit of insight there. And this is a local time here across the bottom. So it is a neat product. We use this a lot in some of our discussions and interpretation of the winds with the port, which gets us into timing of how things might play out. And so what's neat about this is it allows us to not only use our forecasts, but assess what basically about 70 plus weather models are saying in one picture. It's a lot to digest, so it's a statistical analysis is the way to go. And so again, this was just weather.gov/DSS port. I won't go through everything in here. You know, you have your hourly weather forecasts at different locations, which we talked about. And at the very bottom, just keep scrolling down. A lot of great links down here. These are all worded forecasts. So if you still want to read the marine forecast, you can interact with those there. And a lot of great websites in here as when it comes to marine support, especially the Southern Chesapeake Bay Ports page hosted by the National Ocean Service. That's a great resource. So we've tried to put everything in one spot. If you think of something in here that you'd like to add or something you think that might be missing, definitely reach out to me. But that's all I had. So I appreciate the time and give me a chance to kind of go over what to expect this winter. And if there's any questions, I can take them.